Hi, my name's Alan McGinlay. I'm an ecosystem architect here at Venafi. This demo attempts to answer a question you may encounter in the enterprise if you're using PagerDuty alongside Venafi TLS Protect for Kubernetes, often abbreviated to TLS PK. How can you be notified that an observed machine identity requires your attention? Now, if you've tried out the recent Microsoft Teams demo, you'll recognize many of the following steps. TLS PK is the perfect tool for managing cert manager instances across a fleet of Kubernetes or OpenShift clusters. That said, when everything's running smoothly, the contents of the TLS PK dashboard are unspectacular, so perhaps you don't want it front and center at all times. To efficiently protect against outages, you need a mechanism to draw your attention back to the dashboard when a noteworthy event occurs. That's what TLS PK notifications are all about. In this exercise, you will register just one disposable cluster within which you'll create a cert manager certificate, which TLS PK deems to be unsafe or unusable. With the appropriate configuration in place, TLS PK will notify you via PagerDuty that a noteworthy event requiring your attention has occurred. The instructions you need to follow are indicated on screen at this URL. Otherwise, just follow me. To complete this task, you need a TLS PK organization with the PagerDuty integration feature enabled. You also need the ability to create instances of services and integrations in PagerDuty. Finally, you need a disposable VM. We'll start by building a lightweight cluster. Note the TLS PK helper script is not the only way to build disposable clusters for use with TLS PK, so feel free to complete these steps with whatever tools you choose. From a bash session on your disposable VM, download the TLS PK helper script. Set up the TLS PK service account credentials into environment variables. These can be generated via this page in TLS PK. Follow the instructions in the documentation that show how to set this up. You can check this has been done successfully as follows. Now we can begin using the TLS PK helper script. First, we're going to install the dependencies required. The major dependencies here are Docker and K3D. Create a nickname for your cluster, in this case PagerDuty Demo, and then create the cluster. Deploying the TLS PK agent on your cluster will cause that cluster to become registered with TLS PK. Deploy the agent as follows. After a few seconds, navigate to your new cluster in TLS PK to confirm the cluster has been successfully registered. If you click through on the cluster, assuming Show System Certificates is deselected, you should see No Certificates. You will also observe a Configure Alerts button. Keep this page open as you'll return here shortly. TLS PK deploys Cert Manager via the TLS PK operator. Install the operator now as follows. With the operator in place, we can install Cert Manager as follows. You can check that Cert Manager was successfully installed as follows. Now we'll turn our attention to PagerDuty. To complete this task, we will need both a service and an integration. You should note PagerDuty expects a work email to be provided during its sign-up procedure. The domain of your email is used to build a PagerDuty subdomain, which determines the workspace you get admitted to. To provide isolation whilst you experiment with PagerDuty, you may prefer to set up an email address against a personal domain, as I have done. From your personalized PagerDuty homepage, select the Services tab and click New Service. Provide a meaningful name for your new service and click Next. When requested to assign an escalation policy, select the existing policy name default and click Next. On the Reduce Noise page, turn off Group Alerting and click Next. Finally, on the Integrations page, select the tile labelled Events API v2 and click Create Service. The Summary page describes the capabilities of your chosen integration and presents you with an integration key. Once your integration is in place, you'll be taken to the Service Integration screen for your new service. On the right-hand side of the screen, locate the integration key for the Events API v2 integration. Back in TLS PK, with your cluster selected, click the Configure Alerts button introduced earlier. Select the integration type PagerDuty, provide a meaningful name, paste in the integration key you obtained earlier and click Create. There are a variety of certificate states which TLS PK categorizes as high risk or error states. In order to test the PagerDuty integration you set up, you can create a single invalid Cert Manager certificate that references a non-existent Cert Manager issuer. You can do this as follows. Navigate to your PagerDuty homepage. This dashboard page will be titled Incidents on All Teams. Within about 1 minute, assuming no other activity occurs, you will see an alert regarding the certificate you just created. Please disregard any alerts related to certificate requests. For the certificate alert, click the link that reads Show Details. Each TLS PK alert in PagerDuty is accompanied by a View in TLS Protect for Kubernetes link, taking the user directly to the high-risk certificate as reported in TLS PK. Click the link and keep the page open as we complete the next step. Here you can see the certificate is considered unusable. Obviously, the intention is to address each alert, and this one is no exception. The certificate entered an error state in TLS PK because the self-signed cluster issuer did not exist when the certificate was created. Let's introduce that missing issuer by making an adjustment to the TLS PK installation manifest. When a desired state is not achievable in Kubernetes, it will continue to retry. With the missing cluster issuer now in place, the Kubernetes secrets for the certificate will be issued, and after about 1 minute, the error state shown in TLS PK will be rescinded. Here you can see the certificate is now ready. The example you just saw was simple in the extreme. One cluster, one certificate issued one way, and only one failure mode. Imagine scaling this up to dozens of clusters which may not even use Cert Manager yet. Imagine hundreds of undocumented certificates built without modern guardrails and sleepwalking towards expiry. Venafi TLS Protect for Kubernetes provides the capabilities needed to enable effective machine identity management for OpenShift and Kubernetes clusters in the enterprise. So look out for more demos like this, revealing how effective machine identity management can accelerate your cloud-native development and prevent application outages or security breaches. Thank you very much.